Hi Bill, apologies for adopting this rather one-way method of conversation with you about this. I'm a little bit uncertain about what the calculators are doing when I try and use them to solve your first problem. So I'll just show you what I think, and perhaps you could help me out by telling me how wrong I am. In this first problem, you'd begin by choosing the statistics. Oh, sorry, I'm on a Casio too here. We'll get to the Texas issue in a minute. You'd start by choosing the statistics option, and then we'd go for test. Now, I think we're doing a Z-test here. That is testing a population that we're assuming is normally distributed against the behaviour of a sample that we've taken. Now, I think we're doing a one sample thing here, and I also think that the type of data that we've got here is we've got a variable. I think you'd pick list if you actually had some data, so you had 36 separate measurements. But I think that what we're doing here is we're using the variable mode here. The next one I'm fairly clear about, that's the hypothesis. I think I fed in the correct mu. 10 is the population mean. Sigma is the population standard deviation. X bar 9.1 is the sample, and n is the sample size. We've got some graph stuff here, and finally we're down to execute. I think I'm fairly clear here. Obviously, to get it all sort of visualized for the students, one would go for draw, and this is a very reminiscent diagram, and I've done one for the problem in the text that you'll see. I've sent you the first 2 pages of the text. Now, what I'm a bit concerned about here is why we've got a Z curve. I don't follow why we don't get the curve that relates to the particular data, since we've filled in that particular data. And I'm also unclear here about what this p-value is. So if I exit backwards and press calc, again, I've got some figures here that I don't quite understand. The Z value here seems to me to be the value that we're looking for, but I don't quite see how to relate it to the decision that one makes about whether the datum, whether X bar lies within the accept range or outside it. And I would greatly appreciate your help with this. Here we go again, and I'll now butcher this example using a Texas calculator. You probably realised I'm using an emulator here, and the emulator for Texas is actually a CAS calculator, so I'm having to avoid using any of the CAS capabilities of this. I think one would begin with a new document, and I think it needs to be a lists and spreadsheet. Menu statistics stat tests seems to me to be the next thing, and where have I gone? Statistics, stat tests, and a Z test. Now, data input method appears to be the same thing as we had before. That is, I don't actually have data from a sample, but I do have the statistics of a sample. So I'm picking that one. Now, I haven't got my data prepared here, so I've got to put it in. That's 10. Enter 3 was the standard deviation. X bar, I seem to think, was 9.1. And N was 36, wasn't it? Now, our hypothesis was, I can't remember, was it an equals? I'll put it as an equals. No, wrong. This is the alternate hypothesis. We've bypassed the actual hypothesis. Draw shade p-value. Again, as I've said to you, I don't really know what this p-value is. or how to relate it or help the students understand it if I'm putting this into the text. Okay, here we've got the picture that was pretty much as we got off the calculator. Again, my question is, why on earth is it a Z? And I would appreciate your help. Again, we seem to have exactly the same numbers as come off the calculator here, but I can't quite follow why, how to interpret them or what to say in the text about this. I do think it's important that we have these calculator examples in the text. And again, as I say, I'm a complete duffer with this. I don't really know what I'm doing and would greatly appreciate your help.